All right. I never quite trust that the stream starts when the stream says it starts. So I'm going to just give a little bit of filler here. Welcome, everyone, to the stream. We are rolling here a little later than my usual time. So thanks for joining wherever you are around the globe. Today, we are talking to Xusheng about time travel debugging integration, WinDbg integration, and Binary Ninja, which is definitely a tool that has not only been around for a while, and I actually have evidence of that. We're both sporting Binary Ninja shirts.
Yeah,
I was given mine from Jordan himself at DerbyCon in 2016, and seeing your shirt, I was like, I think I still have that in the closet, and here it is. So I got my Binary
yeah,
Ninja shirt tonight. Um, and talking a little bit about WinDbg. So, welcome to the stream, everyone. Next stream next week, and then I'll be off for a couple of weeks doing some travel for work. So, stream next week with Hannah Kane. We'll be talking data sciences and machine learning and a little bit of AI. So, hope you join us for that. But so, welcome. Um, Want to just maybe get started? A little background
yeah,
information: who you
yeah.
are, what you do for Binary Ninja, what are you passionate about outside of TTD?
Sure. Yeah. Hi, my name is Xusheng, and I'm a software developer at Vector 35. And obviously, I work on Binary Ninja, particularly on the debugger. So I write our debugger pretty much from the scratch. And hopefully, you have tried it and it worked for you. And so I have a lot of passion in debugging, and I'm also interested in malware analysis and code obfuscation in cybersecurity. It's like, yeah. Beside that, I also play chess a little bit.
Ah, okay, a little bit.
Yeah,
Yeah, I have the
yeah,
app on my phone. My kids asked me if I could teach them a couple of years ago, and I'm like, yeah, I can. And I didn't really actually know how to play. I couldn't remember, so we started playing a little bit more regular. And
yeah,
yeah, they're like, I don't like playing with you, Dad, because I'm not that good, but I don't let them win. I'm like, well, when you beat me, it's because you beat me. It's not because I let you. So I guess
yeah.
we'll see how that approach works out in the long run.
Hmm.
When did you join Binary Ninja? How long have you been there?
So I have been with the team for 5 years, and we have been around for 10 years. So I'm pretty much one of the not so early, not so late
Yeah.
employees. Like, yeah, you definitely surprised me when you said you have the shirt back in 2016. It's not surprising to me that you have the shirt. It's surprising to me that we have the shirt in 2016, even potentially before the product itself is announced. So we have the
Well,
swag early on. Yeah.
yeah, and I've learned to not trust my memory nearly as much as I used to, or maybe I've just learned to recognize how faulty it can be. Um, I want to say that's where the shirt came from. Jordan might have sent it out after the fact. I don't
No,
recall
no, no. I mean,
100%. So yeah, I could be
yeah,
wrong, but I've had it for quite a while. I know that for sure. And
yeah,
it hasn't been relegated to workout t-shirt like a lot of my other conference t-shirts are
yeah,
that are missing sleeves now and worse for the wear. So, so
yeah.
yeah,
No
I think
worries.
they're
It's official. It's official. Josh had the T-shirt of Finding Ninja in 2016. No questions
okay.
asked.
Yeah,
It's official.
let's get it
Yeah,
on Wikipedia. It's now truth.
yeah, it's true.
Yeah,
Make sure all of the LLM see that.
yeah, right. Because at the end of the day, that's all that matters. As long as it's on the internet somewhere, like Wikipedia, they'll all regurgitate it, and it'll be
Yeah.
everybody's going to be asking. It's going to be a trending topic after today. Well, yeah. So cool. Did you start with working on the debugger? Was that your role when you started at Binary Ninja or Vector 35 5 years ago, or were
Uh,
you was that
Not
your intern?
exactly. So I have been working on the debugger for 4 years, but the first year was I started as an intern for a couple of months, then turned full time, like the regular path, right?
Yeah.
So I
Okay.
was working on. I created our type cross references system. So when you have
Oh,
a
okay.
enum, or sorry, when you have a structure, you select a field in it, you see all of the functions that references that. So that is a type cross reference, and I also did all of the x86 intrinsic lifting. So we now can claim we have lifting support for all of the x86 instructions, which is like maybe 15,000 or something. But not
Oh,
many of them are having an actual lifting. They just be lifted to the intrinsic, so that in the decompilation it shows up as an intrinsic, although internally we don't understand of the data flow or anything, but at least we track the data flow, like this instruction tends this variable, this instruction consumes this variable, so that if you want to write a tent analysis or do analysis on it, we know these instructions are changing this value, are writing to this value. So that's
Oh, okay.
the x86 intrinsic. There is no way to have a dedicated lifting for every of the 1500 instructions. You think of AES instruction and you want to lift it, you have to implement AES in Binary Ninja IL, and good luck with that. Yeah.
Yeah. Okay.
Yeah. Yeah.
What?
And so in my latest 4 years, I'm also not really only focused on the debugger. I still do many of the other things because our team is pretty flexible. Like you do whatever you want. So I also did other
Oh,
things
okay.
different from the debugger, which means the debugger is not getting better in the speed that I want because I spend my time on other things and I only have these many time. So yeah.
Yeah, yeah, I can relate. I think at least I find myself infinitely curious and almost always willing to say yes, even though I oftentimes ignoring the confines of time and space, and that I just don't have all the time in the world. So I understand. Well, I mean, Binary Ninja certainly. I think I was very fortunate early in my career, early getting into cyber anyway. A good friend of mine was good friends with Jordan, and I believe still is, and was invited to do a talk with him and get my hands on Binary Ninja fairly early. I have to admit, I really had no idea what the heck I was doing at the time, and but yet I had folks that were just utterly confident in my ability, and so go dig up that old DerbyCon talk, and you'll see it was a struggle for me. I think we had like 45 minutes to talk, and I was given a half hour or something, and I got up there and I was so nervous I was done speaking in 15, 20 minutes. It wasn't good. It was a very nerve-wracking experience for me. Hey, Casually Joseph, nice that you're here.
Hey.
So with TTD, I mean so I was kind of surprised. I was actually, I shouldn't say kind of. I was very surprised that as when it finally kind of dawned on me that this time travel debug's a thing, that it's a part of WinDbg, and this wasn't that long ago, that it actually had been out for several years. I think 2016 or 17 is maybe when Microsoft announced it or released it publicly. I imagine they've had it internally for longer than that. It seems that in our, at least in our field, reverse engineering and some malware analysis, there's still kind of a slow adoption, and I think part of that maybe is just there's some hesitancy to use WinDbg. There's a little bit of a learning curve with WinDbg. I don't think there's a ton of learning curve with TTD, although there is a learning curve with it. I don't know. When did you get interested in TTD, and what motivated you to integrate it? I mean, Binary Ninja first to have TTD integration like it does, that you can just replay the trace right in the UI, and you have full command support and all sorts of great stuff. So can you tell us just a little bit about that?
Yeah, sure. Yeah. So, well, I think Microsoft released WinDbg with TTD support in 2020-ish. So, not something like 2016. That's not official. So I think it's
Okay.
like 2020-ish. Yes.
Okay.
I think the reason. So first of all, time travel debugging is not a new thing. It's not a new concept. Like the Panda RE has existed for many years. But the problem is Panda RE is like a full system record and replay. It's also kind of slow. Well, sorry
Hmm.
for those Panda developers, but it's not really very well geared towards practical use. It's a good academic tool, but it's not really very usable. I think the turning point of TTD is in recent years. Not only Microsoft released a WinDbg with TTD support, also we see eShard has ES reverse. It's also a full system emulation. Sorry, not a full emulation. It's full system record and replay, but it's very fast. And also we have RR and undo. So these are all more practical solutions. So I said that in academic, the idea of time travel debugging has been discussed maybe 10 or 15 years ago, but without having a actual usable product that is not going to be adopted for the majority of the people. And also, as you mentioned, so malware folks are adopting this slowly. I think one of the reason is that TTD is, at least from some of the developers of TTD solutions, they are actually targeting developers. They are trying to help people fix bugs. They are not
Yeah.
considering the practical application of malware analysis or reverse engineering use of this. So in this sense, I think I'm kind of the first to actually try to bring things together. So whenever I talk to the TTD developers at Microsoft or developers at Ondo, they think this is actually an interesting use case of that. And so I integrated the TTD into Binary Ninja because I see a potential of this technology to enhance or improve reverse engineering. Because once you have a trace for the sample, you can do a lot of things. You can not only go back and forth in history, as we will see today, you can do analysis on it. That is like maybe 10 or 100 times more powerful. So I just went ahead and integrated that, and they also have a API for their accessing the trace. So it's pretty nice. And so the so we have the plans for integrating with all sorts of backends. Can you briefly share my screen to the users? So we have
Yeah.
now integration with WinDbg. We have integration with ES Reverse. We also plan to integrate with multiple backends. So it's not only like Binary Ninja plus WinDbg, it's Binary Ninja plus TTD, and you can have multiple backends integrated into that. So, or even you have a custom emulator, let's say based on QEMU, we can also integrate with that. Yeah, cool.
Okay.
Can you switch back?
Yeah.
So yeah, that's the my vision for TTD is so TTD is basically. Oh, can you share that again a little bit?
Sure.
So one of my friends is saying TT time travel debugging is a paradigm shift in debugging. I know who said that, but I'm not sure whether he wants to be credited here. So I
Okay.
didn't give the name of the person saying this, but I think it's a very strong word, paradigm shift. So basically, my take is it has precise and abundant information about the execution. So an important aspect of utilizing TTD is actually to extract and utilize this information to help you do malware analysis, to help you do reverse engineering, or help you do vulnerability research as you fit. Yeah.
Okay.
Cool.
Just
You
have
want to
to,
take it back?
yeah, let me know when you want the screen back.
Yeah, I want the stream back now.
Ready. Okay. So funny enough, we got an infinite screen thing going. I had issue. I'm having issues. I've had one of those weeks. I don't know if anyone else has ever experienced this. I imagine you all have, where it just seems like technology fights you at every step of the way. And I don't know what's going on, but my streaming platform here just decided that I can't share windows. I can share tabs, but I can't share windows. So we're a little bit at a disadvantage today because some of the streaming we had planned me sharing, and I didn't find out that I had an issue until it was a little too late. So, but that's all right.
Yeah, I
That's
mean,
what live streaming
I
is all
can
about.
do I can do all of the streaming. But if you want to talk more before we do that, just go ahead and
No, I
I'll
think
be alone.
we jump right in. The TTD. Yeah. I mean, paradigm shift. I think they're kind of two ways that I've been looking at it, and the first was very simplistic. Hey, I can record a trace, and I can go backwards and forwards without having to restart my debug session, and that's pretty cool. I really like that. And then I realized that there's this whole debugger object model underneath the hood, and that's I think what you're referring to, or you are referring to, as the much more powerful capability. Now you can query the execution trace to understand behaviors, properties, characteristics of the trace without having to go through and actually do the debugging. And I think, we're kind of still at this manual level, executing commands within an interface like Binary Ninja or within WinDbg itself. But I'm excited for all of the ideas, and I think the different ways in which we're going to find maybe is if this API gets more well known and a little bit, I don't know, sounds like maybe it's not all that well documented, because I know there's some projects out there like Airbus. They have a TTD integration for, I think that was for IDA at first, and they reversed the whole thing. So that
Yeah.
sounds kind of sticky, for somebody who wants to get some automation and stuff. And that's really, like once I started getting into the debugger object model, that's kind of the next thing on my mind. Like how I should be able to create this entire framework, this tool around interacting with these traces and telling me everything I need to know and make it really easy to query. Not that the query language isn't hard. It doesn't roll off the tip of the tongue, though. I'm always constantly checking cheat sheets and trying to remember syntax. Or WinDbg has the DML, the debugger markup language. If I have to, I can actually click around to see the hierarchy of the objects and the namespaces and things like that. That can be kind of helpful. So,
Mhm.
yeah, I say let's get into
Yeah.
the demo, or whatever
Yeah, sure.
you think is next would be a good next step here. I know you can capture, you can really, but it seems like you pretty much do everything in Binary Ninja at this point, can't you? Capture traces and
Yeah, you can do most of them, but some of the things are not as powerful as if you do it in WinDbg. So, like
okay,
talking about capturing a trace, we only support launching a process and run it. It doesn't support attaching to a process yet. It doesn't support some other use cases that is supported in WinDbg. But
okay,
those are not really, substantially difficult to do. It's just I need to take the time to do it. So, uh, right. Well, I mean, sure. Let's start with some of the basics of the WinDbg. I remember, Josh, you actually had a video series on using Binary Ninja WinDbg, like how to set it up and also capturing the trace and also playing with it a little bit. And let's just briefly recap it because some of the
yeah.
viewers may not actually have that experience.
Yeah,
So,
if you want to check out on the channel, I've got a series. It's like straight from the documentation. So it's
yeah.
just for those who want a little bit of an explanation. It's really I found the documentation to go really well hand in hand with what I decided to record.
Yes. So if you haven't done this yet, the first thing you want to do is to do debugger install WinDbg/TTD. I already have it installed, so I'm not going to click it here. But what happens is just basically you click it and Binary Ninja will download the WinDbg and install it for you and put it in a position that is accessible by Binary Ninja. Because what this integration does is basically Binary Ninja loads the WinDbg DLLs and calls some of the API. So you would have to have WinDbg installed. Um, that is the first step. Basically, it's a one-click thing. You just click it and it will be installed. So there is not much to talk about for that. And then after that, whenever you open a binary, you can click debugger record TTD trace and you put your executable here. You put the working directory here. If you have any command line arguments, you just put it here. And also, potentially, most importantly, is the trace output directory because you need to know where to find it. I'm just putting it in the same directory as the executable. It doesn't matter because as long as you know where it is, you're good. And you
Yeah.
just click record, and it will show up a UAC dialog. I'm not really sure whether you guys can see that,
No.
and then you just say yes. And you see it's pretty fast. Now, I'm using a hello world binary, which is admittedly very small, but you also see the tracing almost finished like in less than a second, right? And you
Mhm.
see this is the command line it actually executes to get a recording. And it's just actually running the TTD recorder from the official distribution of WinDbg. Uh, and now you can see
Yeah,
we have,
and for anyone who's maybe a little new to TTD, it's meant to be is like thin of a layer between the executable and the operating system. So it's not like in a sandbox or anything. I guess is all I'm trying to say is it's going to do whatever it is. Program's going to do whatever it's going to do. So you still have to take all of those precautions when trying to trace anything malicious or that you suspect is malicious.
Yes, if you have a malware, you want to trace it in a sandbox. I'm using running it on a real box, but
Hmm.
because it's hello world, it doesn't matter. But if you're using malware, you probably want to trace it in a sandbox and also debug the trace from there. Maybe after so maybe you run the malware and you get the trace and you copy it back to some different machine. Then you can have the trace and run the analysis on the trace from there. I believe when you actually replay the trace, it doesn't actually run any of the code. It's just emulation and replay. But don't take my words on that. So, you know, yeah. So as you can see here, two files are produced. Hello world 03.rom, that is the trace. You can see the size is not very crazy. It's like only 24 megabytes compared to the sizes of the modern disk. I would say that is pretty small, right? And it's also a .alt file, which is the output from the command line. So what we're going to do next is we're going to first of all switch to the debug engine TTD debug adapter, and then it will ask you for the trace path, and we can just put it in the path of the trace. Hello world 03.rom. Now, of course, it's named Hello World 03 because I have Hello World 02, which I did earlier, but you probably get Hello World 01.rom if you are trying this for the first time. And then we just click launch. Now, of course, it will see, well, yeah, okay. So when we are launching the trace for the first time, it will say the trace is unindexed. So one of the things it will do is it will index the trace. So when you launch a trace for the first time on your machine, it might be a little bit slower, but that is totally fine because it's spending time indexing the trace. And once the trace has been indexed, the subsequent launches should be substantially faster than this. Okay, so now we have launched the trace, and you can see we have the RIP here. We're at start, and we have the stack tree, the modules here. We have the stack trace. So one of the things you might notice already is we have TTD record DLL in the loaded modules. So that is actually how WinDbg implements the recording. It injects a TTD record CPU.dll into the process space and somehow instruments the process to do the recording. Now, of course, we're not going to get into the details of how they actually do the recording, but just be aware when you see this DLL, don't get surprised, right? So this is the usual debugger interface on the left side of the side. This is left side of the window. This is the debugger sidebar. We call these things sidebars, if you do not already know. So as you can see, we have all of the familiar buttons you used to, like step over, right? You can step into. When you do step into, you just go into the function, or you can see it more clearly if we're using the graph view. So the cooler thing is we do have ways to step back. And you can see when I step back, if you monitor the value of registers, particularly the RAP register, you can see that it actually rewinds as I press it, right? So basically, you can maybe go to the main function. Okay, it doesn't work. All right, I didn't. I thought I put a breakpoint here, but I didn't because obviously the breakpoint doesn't show up. So you can resume it, and we'll go to the main
Well,
function.
but that
Or
right
maybe
there is a great use case. How many times I've been looking at something, especially that has a lot of convoluted control flow or obfuscation, and you're kind of in that trial and error mode of I don't want to have to spend any more time in this than I have to, so I'm setting breakpoints, and sometimes they don't hit, and then I've got to restart the whole darn thing. And so like this right here is just, this alone has been a massive time saver for me in so many scenarios. Just, oh, I went too far, missed the breakpoint. Well, I'll just reverse, rewind, and try
yeah,
it
yeah,
again. It's just great. I mean, that alone is great.
yeah, yeah. Let's see. maybe I should press step over. I just press the resume, right? In real world, like not TTD, it will just run and exit. You have to restart. But in this case, it actually just goes to exit process, and is actually at the end of the trace, which is a system call to exit the process. That's the end of the trace. But what I need to do is I just need to press go backwards or press Shift plus F9. There's a shortcut on it as well. It just goes to the last place where you were at. That's super cool because, as Josh said, when we are doing debugging, human errors are unavoidable or even very common, and that wastes a lot of time when you're actually doing debugging. So having a trace recorded on file so you can play with in whatever way you want is really an advantage. Also, so speaking of malware, we have sometimes those C2s are very smart or sensitive of how many times you can actually communicate with it. Some of them only allow you to download the payload for maybe once or twice, right? So if you're debugging it regularly, you will hit that limit pretty soon. But if you already have the trace, you will have the second stage already recorded in the trace because it's downloaded from the internet and everything is saved. So you can safely play with it without having to worry about whether your IP will be banned or something like that. So another thing I think Josh also shared in his video is basically you can do what is the command for a single step? Is that T? I think it's
Yeah,
T. Okay,
I think it's
it's
T. Yeah.
T. It's T or S. So one of them actually does a. It's not S. Okay.
Yeah.
Anyways, so T goes forward and T minus actually goes backwards, right? And G goes forward
G
and
goes for yeah.
G minus actually goes for backwards. So you can
Yep.
use commands here, and also you can run whatever. If you're a WinDbg power user, you will love Find Ninja Debugger because you can also run all of your favorite commands here. It doesn't work. Oh, it works. Okay. Well, it's case sensitive. I didn't know that. So you can run pep and get whatever information you have, right? So these are the basic interactions with WinDbg. So I think one thing you didn't cover is about running queries in WinDbg. So WinDbg has a data model. I can't remember the commands every time I need to look it up. So
Yeah,
basically,
I do too.
yeah. So there is a data model in WinDbg. So you can actually run this command and let me show you. So yeah, let me put some real values here instead of these placeholder. So dx means display, and -d I believe means put it in a table. So what is important here is current session.ttd.memory, which means you are querying the memory of TTD in this current session. Well, that's a terrible explanation, but you get the idea. So you have a start and end, and you specify what kind of access you want to query. So I'm putting E here, which means I want to query all of the executed instructions, and I put the start and end of this basic block. So basically, what you are trying to do is you will query all of the instructions that has been executed, and it should just be okay.
I believe it's at ampersand dollar curse session.
Yeah, that is the problem of running these queries by hand. It's like this.
Yeah, let's give that a shot.
Okay,
There
cool.
we go.
Yeah, okay. Yeah, so it's a lot of trial and error every time, right? So, but you do see the result here is it gives you a list of results. My font is huge, so it's a little bit hard to read, but it gives you a table. You have all of the event type, thread ID, unique thread ID, time start, IP address, and also a few other information. Now, what I'm going to show here today is not you can run this in this console. You can already run this console back in I first created the integration, you can do here is you can select the range and just right click debugger TTD memory access and select execute and just click it. And we have this nice table that shows all of the results here. That saves you from having to memorize all of the instructions. And also it's a table, so you can double click and do the navigation easily. And here is the
Oh,
time
sure.
step. So if you double click on the time step, it does two things. One, it time travels to this particular time step. Two, is navigating to the IP address. So if I'm only double clicking on the IP address, I'm just going to this particular address. So the instruction pointer is still here, which means I just want to, okay, look at the code at this particular instruction. But if let's say I want to go to this particular instruction, I can double click here and it actually does a time travel plus navigation. You can see the instruction pointer is now here, and you can see the RIP also matches here. And you can see RCX is actually showing hello world. So this is the query. One of the query you can do is basically you can query all of the executed instructions. And we have so this tab is also this widget is also multiple tab, so you can actually create your own tab and also put things here and just check all of these things as you want, and you can create how many you want for it, right? So another
Oh,
thing
sure.
you
Is
can
that
do,
just the time travel command then that's navigating the TT?
yes, the TT.
Yeah. Okay. Yeah. So there's of course there's a command line option in WinDbg to do all of this as well, which is just that extra step of having to do it in WinDbg. But the TT command is what allows you to time travel to a sequence event, which is that time start, that format that you see in that time start column.
Yeah.
It's like event and then the number of steps within the event. And the events are just sequencing objects that TTD trace uses internally to make sure that everything stays in order.
Yeah. So another thing I want to demo is you can also query all of the read and write. So I'm selecting this string hello world, and I'm right click on it, debugger, TTD memory access, and read. So it gives me this table. Let me explain this a little bit. So we still have the index, which is not surprising. It's just the increasing number, and also the time start moment that this particular bytes are read, and also we have a access type column, which is read, which means which when these bytes are read. So we now have a address and IP column. So if you remember here in this query, in the execute query, the address and the IP are the same because IP is the IP of the instruction and the address is the address of the executed instruction. And they are of course the same, right? But when you are querying for read access, sorry, these are different. So the address is actually the address of the string. You can see here, the first address is actually the start of the hello world string, right? You can see it ends with 2210, and it also ends with 2210. And everyone is incrementing by one, which this means these are actually sequential access to the string. But the IP is actually a little bit different. So the IP is actually the instruction accessing the data. And of course, the instruction is going to be different from the address. The address is the address of the thing that is being read or write to, if you also check this. The IP is the instruction of the instruction that actually does the read. You can see the IP are all the same for these charts, which is reasonable because I think it's somewhere inside of a printf. Yeah, we have no functions here because that is part of I guess it's probably libc or something. We can actually time travel to that. Yes, and we can see the stack trace, which will be making more sense. You can see we're inside of URC UCRT base, and some of the functions we don't really know what it is. But you can see it's actually inside of printf. So yeah, we can go here. So this is the point where we are calling into printf, or maybe on this function, if you are, it will be easier to see. So of course, the printf function will have to access this string, but we usually don't know where it happens, right? But with TTD, we can now see it's actually happening in the CRT Studio STDIO output : output processor. Yeah, this is a really long name function. I'm not going to read it, but this is one of the ways you can see where these things are being written to, being read, right?
That's
Yeah.
usually
So that's
7 layers deeper into printf than I normally go as well.
yeah.
But it's a good, very
So
good usage of just showing the memory access.
yeah. So let's say you have a malware and it has an encrypted string. You can actually just just do what I did, and you will see when the byte is read and when the bytes are written to. So you can see, you can effectively just find out the decryption function, because the string decryption function would have to access the memory of the encrypted strings anyways, right? No matter where it is hide, like maybe even it's hiding in 7 layers of functions. It doesn't matter. You just do a TTD query and you see where it happens. So this is for TTD query. Now this is unfinished yet. I do plan to make it even more powerful, but I just don't have the time to get to it. Oh, by the way, so I'm actually running a test build. Um, a test build is a build that we use internally for development. So this is actually not yet public to general users, but I
Yeah,
guess
I
I
was
will
just
ship it to.
gonna. Yeah, I was just gonna ask you that. This is an internal? Is widgets that we're talking about are all internal?
Yeah, internal. I
Yeah.
mean,
The
these actually
trace
looking good.
the traceability is in the free version right now. Right.
Yeah.
So you can record a trace. You can start stepping through the trace, but the widgets that you're showing off are not.
Yeah, this
Okay.
particular TTD memory widget is something that I'm working on and is not released to the public yet. But I guess it will be soon, because it's actually already pretty cool. Like definitely usable, but
Hmm.
just I haven't finished everything I want to add. So I mean, yeah, you guys can also let me know whether you want to see a more polished one, or you guys want to have access to it as soon as possible. Just put it in chat so that I can know it.
Yeah, absolutely.
Yeah, okay. So another thing is we also have a ttd.calls query. So let me show you. So inside of the drop-down menu, we have calls to, you can query calls to DLLs. As an example, I will be querying all of the kernel 32 calls here. So what it does is it actually runs a query on the kernel 32, and also putting it means, can you guys see the font? Is that large enough? I mean, this is a new widget, so it doesn't actually respond to the enlarged font. You can see all of the code here is having a enlarged font, but this widget is so new, it doesn't actually respond to that. So if you can't really see it, maybe just watch the video afterwards and maybe
Oh
zoom
yeah,
in a little
you're
bit.
getting
Sorry.
some feedback here. There's just so you're aware, there's a little delay between the stream and when it actually goes out onto YouTube. So when we ask questions and stuff, you got one user, I want it now, and another user. Sorry, I'm not gonna try to pronounce your names, but ASAP. We can always polish it later. So 2 votes for get it out.
Sure. Yeah. So
Um,
here is we are querying. Are you done with that, or we have more feedback? Because I
no,
cannot see that.
yeah, no, you got a little feedback. Font could be bigger, but it's good enough. And
Yeah.
I'm gonna try. I can actually do a little bit of zooming, but it's not controlled zoom. So I'm gonna just zoom in a little bit. Maybe this will help. And then if I start cutting off parts of the screen that you need to show, let me know.
I wouldn't be able to know because
Oh
I
yeah,
can
you
only
probably
see
can't
my.
see this. Yeah. Okay. Well, I'll use my
Yeah,
expert broadcasting skills to make sure that I zoom back out.
yeah.
So okay, no, I think we're good now.
Cool. Yeah. Okay. So I just queried all of the functions that has been called in kernel 32, and using a heuristic here, it means matching all of the functions that has been called. So you can see here, we actually during the execution of this program, actually 20 of the functions are called in kernel 32, but not all of them are done by the main executable. So maybe NTDLL also calls a function in here. So what I have prepared is basically you can filter on the return address, and you can limit the return address to the range of the hello world executable, and that will actually give you all of the calls that has been made from the main executable. Now, of course, unfortunately, it doesn't work today because when I put the return address range here, it will just crash. But I will fix it so that you can filter all of the calls here and to only give you the calls that are made from the hello world executable. If I remember correctly, you will be only getting two of these instead of 20 because kernel 32 is busy. Many libraries calls it, so but not all of them are interesting to us. For example, this one is definitely interesting to us because it's calling get startup info wstub, which I remember is called from get startup. Okay, it doesn't work. Um, well, and I'm stupid. I can just time travel to that and see the call trace, stack trace here. It either hound or hit a bug. It shouldn't act. Yeah, okay. Okay, well, thank God it worked. So this is the call trace of getting to this function. And oh, that's a long one. Yeah. If you're curious about how Windows actually initializes a new process, you can actually see what it does. But I'm just going to go to our code is basically it's called okay, it's called an exit. Oh, that's interesting. Why does exit call get startup info stuff? Anyways, yeah, it's in common exit.
Hmm.
Yeah, it's
Yeah,
interesting.
I'm not sure. Yeah.
Yeah, I think it's an interesting behavior of Windows we don't really understand pretty well.
Whoop.
Yeah. So the fatal exit is actually just exit process. We can see this one. Yeah, this one is a little bit easier to see.
Mm-hmm.
Yeah. So yeah, it's 2F is right after the call to the exit function. So calling exit, which is the UCRT exit, actually leads to call to exit process. This is not surprising. This is expected, right? So when you call exit, it just eventually calls the exit process implementation. So what I'm trying to do here is, as I said, if we have a capacity on filtering on the return address, we can also do filtering on maybe function address, and also you can do whatever filtering on this because I also plan to have API access to this. So you can actually receive the content displayed in this table through the Python API. And of course, it's not done yet, but that is on the radar. So you will have access to all of these, and you can do whatever processing you want. So Now, of course, this query can also be done by running queries like
Hold on.
this.
I'll move us.
Okay. You can also run this query as well, and it will give you the same result. And also, you can, if you want to filter on the return address, I believe you can do this. I have no confidence this is going to be working for the first time. Now, this is the problem of running the query yourself. The query is very powerful, of course, but the problem is you have to remember all of these and type it correctly.
Looks pretty good to me.
Yeah. Well, as I said, so it will only have 2 results. So the same thing can be done in the widget, and we can do more. Like whenever you want to also filtering on a particular time start or time end, but again, you can still do it with this query, but that query is going to be very hard to read, or sorry, very hard to write. You have to remember everything. You have to write it correctly.
Mm-hmm.
It's far more challenging to just say add a filter here. Let's say filter only maybe the time start is after a certain point, or maybe only want to have the return value is non-zero or something, right? So like you can do whatever you want once you have this table accessible. Like you can create whatever things on top of that. You don't have to bother with remembering of all of the query syntax. That's very hard to remember. Well, at least for me. So I don't know whether you agree with that as well. But having access to, yeah.
I totally agree. That's why there's I don't have a public WinDbg cheat sheet, but I certainly have an internal WinDbg cheat sheet that I'm always clicking or referencing so that I can remember what the command is or what the syntax is, or so yeah, definitely.
Yeah,
it's hard. It's
if
hard.
You're generous. If you're generous enough, you maybe want to share that with me so I can see what are the most used commands by you, so that I can add all of them to the Binary Ninja, so that you don't have to remember any of those.
Yeah. Yes. There is a. There is a. I hope to be a part of some public TTD stuff in the near future. So a cheat sheet will most likely be a part of that, and then of course any contributions that I'm helping you with personally, which is great to see.
Okay, so the next thing I'm going to show you is now the 2 widgets I just showed you are something you can already do with a query. Having a UI for that is of course decent, right? It's nice and useful, but it's not actually showing the full power of TTD. The next thing I'm going to show you is something that you cannot really easily do with just queries, because it's a very deep integration with Binary Ninja, also based on analysis. So the first thing, the only thing I have for demo today is a code coverage. So because as we all know, we have the information of all of the executed instructions. So how about we just record that, put it somewhere, and render all of the instruction that has been executed in a different color. So what I have here is a TTD analysis dialog. Now this dialog is all AI generated, so it's not written by me. So if you don't like it, don't blame me. Blame AI on that. So, but I mean, it's pretty nice to see what we have here. We have a address range to index. So and it also defaults to the range of the current binary, because usually you only want to see the coverage information on the main executable you're analyzing. You won't be actually curious in, I believe you won't be curious about the coverage information about kernel 32, right?
Yep.
Or NTDLL. So for performance reasons, these are actually the range of the hello world binary. And also, we just click run analysis on it, and it will run the code coverage analysis. This is a really small binary, so like the run analysis finished instantly. But maybe
Hmm.
on a larger trace, it potentially take a little bit longer. But I have been constantly amazed at how WinDbg's performance is good. It's like
Oh, really?
even if
Okay.
you have a yeah, even if you have a really large trace, you can go through the trace pretty efficiently. So we have a render layer and we have a TTD coverage render layer. Now this is a bug, so it's already on. You should already see the coverage, but you do not. That is because it doesn't refresh, and you just go ahead and toggle it off and then back on, and you can see all of the
Mm.
instructions has been highlighted. Uh, you can see here. This is a function scrt acquire startup lock something. I don't really know what it is, but you can see here some of the instructions are already highlighted by with red.
Yeah.
But can you guys actually see it?
Yeah.
I know the color is not the best, so you can see these instructions are not highlighted, so
Yeah.
which means these instructions are not executed. Uh,
Yeah. That looks great.
yeah,
That was another one of those. I should create some sort of a plugin to make it.
yeah,
I know there's some out there for IDA and stuff probably floating around, but it makes absolute sense. You've got the trace information. You're in a tool like BN. Show me the path of execution. So that's
yeah.
great.
So So you don't have to write that. I already did it for you.
Yeah. Yeah.
Yeah. So we have
Well, for me
Lighthouse. We
and
also,
hundreds of other people, thousands
yeah,
maybe.
yeah,
Who knows? Awesome.
yeah. We have, you know, uh, uh, what I was trying to say. Okay, so we do have Lighthouse, which is a third-party plugin developed by, uh,
Yeah.
I can't remember. Anyways, we also have BNConf, but that's our like third-party plugins. We now have first-party support for that. Yeah. Uh, that's pretty cool. And I also plan to make it even more powerful that potentially, let's say we have a loop here. We can actually annotate at the start of the basic block, maybe say some 10 times, which means, okay, so this loop has
Mm.
been executed 10 times. So I just add an annotation on the top of the basic block because we have that information. We not only have all of the executed instructions. We have the executed instructions and the time of the execution. So we
Yeah.
can very easily just render a thing here and say how many times it executed. And also maybe we can use different colors. Maybe red is for only executed once, and maybe a darker red is like maybe 2 times or even more. Like you think of how visualization can be done. I'm not
Yeah.
an UI expert, so I can do the demo here, but I'm not really sure what is the best way to actually present this. But I'm pretty sure there will be a way to do that.
Yeah.
And
I think
also
so.
potentially we can, yeah, potentially we can also visualize all of the data variables. Like maybe this data variable has been red, we can just put it in the color, whatever color, right? And maybe this is not used, so we just put it like what it normally looks like,
Hmm.
right? Cool. All right. So these are the things I have a demo for. Um, there are still a lot of things I want to build. It's like TTD is a wealth of information. We can do tons of things in TTD, and yeah, I mean, we can maybe show something later, but that's what I have today.
Yeah. Have you? So have you run into any issues like where TTD has just really stumped or frustrated you, generating a trace or just working with the traces that you have been for integrations through the API?
Well, when I do development, I tend to use a trace that is relatively small. So when I do development, I do not really run into issues. But when I actually use WinDbg, it's also a software, right? So software all have bugs. So I
Hmm.
remember I run into one case is basically, like you said, one of the instruction is not properly emulated. So when you replace the trace, you actually get into a wrong state. That is one thing. Occasionally, I also get into cases where I write a bad query, or I just say, "Oh, I want everything in the trace," and it runs really long. Although I do have a better way to query that. So, for example,
Here, I'll
the
pull your script
queries
back.
the queries I did here, if you don't actually limit an address, you don't. If let's say if you don't put a limit on it, you just want to start from 0 all the way up to the max, and you want to everything to be recorded, to be queried. Now this will of course work, but let us try to run it and see how fast it can finish. Honestly, I haven't really tested that. It could be a disaster. It could be,
Sure.
Anyways, let me try. Let us time it. Yeah.
What is BN's way of telling you that it's does this like put a lock basically on the UI then? Is it still responsive?
It is not.
It is not. Okay.
Yeah. So of course the query shouldn't be wrong on the main thread, but I mean I just quickly well I mean
No,
15 seconds, not too bad.
that's too bad. No.
Not too bad. Yeah, that's like how many is this? Yeah. Well, I mean, 173,000 queries are returning 15 seconds. I can't complain for that, right?
No.
That's the everything. Yeah, that's the everything of this trace. Usually, you wouldn't really want to do a query like this. It's like give me everything. That's like one of the dumbest thing you can actually do for TTD. Is like I want everything. It should say no. There are too many results. I mean, I now have a fantastic idea. Well, of course, it's a joke. So we should actually limit how many queries can be returned, how many results can be returned based on your tier. Like you now, well, this is evil. So if you are using the free version, maybe you can only see 1,000. If you're using the ultimate, you can see unlimited.
Yeah, you could do
Yeah.
that. We have a little
No,
dialogue
no.
or a little thing in the bottom of the results grid. To see more, upgrade your license.
Yeah, well, yeah. Well, that is not that the how people do it with AI, right? You have different capacities
Yeah, yeah.
depending on how much you pay, right?
Right, right.
Okay.
It's not
Yeah,
it's
yeah.
not a
That's
it's not a completely out there idea. Um, yeah, and I know just with working with WinDbg, there's commands that once you execute it, it's a one-way trip. And WinDbg is going to
yeah,
process that command until it's done, and you're just along for the ride. I have a
yeah,
we did a workshop at DEF CON this summer, and I picked it's a .NET dropper that drops a .NET payload, and it's kind of typical .NET, bunch of assemblies get loaded and just lots of layers of obfuscation, and then it all ends in process hollowing, and um, but the trace to get to that point was almost a gig, 8 or 900 meg, I think, for just the trace file. Or maybe that's the index. Either case though, it's a really large trace, and so that one you feel the system bog down a little bit if you're not a little careful with your queries.
yeah. Unfortunately, so WinDbg is just like single, well, not single threaded, but this non-interruptible. Like when you're actually
Mm,
running the queries, either it finishes or you just wait. There
yeah.
is no other option. I mean, I can technically run the query on one of the non-UI thread, but that is actually not helping anything because, of course, it doesn't actually block the Binja UI, but you also don't have a way to um, block interrupt it. So, for example,
Mm,
like when you're actually doing search in Binary Ninja, because search can be taking a while. So in Binary Ninja, it's like when you search something, uh, the search results will show up as soon as it is matched. And then you have a button here, you can actually stop it midway. And when you stop it, you actually stop it, the core has a callback. And when that callback returns false, the search will just stop. So you don't have to wait for it to finish.
mm, mhm,
Unfortunately, that cannot be easily done with WinDbg, or
mm.
or at least until we bug them heavily so that they change it. So until that, we couldn't really change anything on
Okay.
this.
Yeah, I
Yeah.
Understood.
Yeah. Yeah.
Well,
Any
let's.
questions for this?
Okay. Well, Bacon, thank you, Bacon, for commending me. I was moving. We've got this feature in the streaming software that allows us to move our inset windows around as you're demoing, and so I was trying to keep us out of the way of where you were trying to highlight and focus. So I appreciate that you appreciate that. That was great. Yeah. Other questions? I think we're going to probably wrap things up in the next few minutes. Definitely. Anytime you want to come on and talk Binary Ninja, and especially if you're releasing features or talking about things that aren't quite out in the public, whatever, you're always more than welcome. So, but if there are any questions, let us know. The recording will be available. YouTube's probably the easiest place to leave comments, just the place that I monitor the most. So if you have any questions, feel free to drop them there if you're catching the recording. Let's see. Question about single step. Let's see. So from YouTube, can I single step in the HLIL view or only in assembly view with TTD?
Sure, you can definitely do that in high-level IL, but it's not guaranteed to be correct. That is not our problem because if you are familiar with compiler, you know how difficult or challenging it is to map high-level IL source code to the underlying instruction. So, like maybe I can show you. Yeah, you can actually do it. Like what I'm just showing you, right? Like in high-level IL, it's you're single stepping ahead of one instruction at a time, right? It works, but it there is no guarantee it's always accurate
Mm-hmm.
because so basically what we have is we have a mapping of high level IO and disassembly. Let me turn off these render layers. Okay. So for example, this instruction corresponds to three disassembly instructions. So when you stop on this high-level IO instruction, it corresponds to three disassembly instructions. And I have to decide where to actually stop, whether we should start on the first or we want to start on the last. So my recommendation is if you're debugging a large function or a sample that is not so interesting. So for example, let's say it's not obfuscated or has nothing special, you can definitely do your debugging on high-level IL. It's more efficient. It's probably better. But if you're, let's say, debugging something that is heavily obfuscated, has all of the wild, uh, let's see, obfuscation, encryption, or other things, I would recommend you to work on the disassembly because that is the only way you actually see the things correctly.
Mm-hmm. Yeah, Flare 12 is just around the corner, September 26th, I think.
Mm-hmm.
Yeah, September 26th. So this will be a great opportunity to test out your skills with Binary Ninja TTD for Flare 12. Hopefully that answered your questions. Bacon says more streams. This was great. So you are requested to come back as a guest. So hopefully we can work something out here in the near future, and maybe this fall yet, or whenever works out for you.
Yeah,
Okay.
yeah.
Well,
Maybe the next time, yeah, the next time I can bring some more demos for TDD and show to people.
yeah, that sounds great. I think that's again, it's one of those areas that I have found so useful. I'm trying to be an advocate, and I think the more the reversing community uses it and gets feedback to the team that's developing it, the more it'll be supportive of both the developers and the reversers. And so that's a great tool, a great framework. I don't know if product is the right word, but it's just it can only get better. So yeah, thanks everyone. I think we've had enough time for questions, so I think we're good to go here. Thanks everyone for joining. Uh, Last thoughts, comments, anything you want to say before we hit the end stream button?
Oh, yeah. Well, I mean, thanks for hosting me here, Josh, and thanks for everyone for joining me. And stay tuned with Josh's channel and also our newest development on TTD in Binder Ninja.
Yeah, where's the best
Thank you.
place to kind of stay up on announcements? I know the Slack. You guys have a Slack, so that's pretty active. I know Jordan's in there, and the rest of the
Uh,
team. Social media, I suppose the
Twitter, yes.
Twitter,
Yeah,
X.
LinkedIn.
Yeah.
We also
Okay.
have a blog, like official blog. Like whenever we have a large feature that is cool enough, we usually do a feature blog. So that will be writing about everything I showed today. And also every time 1 month before we release a new stable, we will have a feature stream, which will be demoing all of the features that we will be releasing
Ah,
in the stable release. And it will be similar to what we do today, but by the time we do it for the feature release, feature stream, probably things are more polished and we will have more things to show.
yeah. Yeah. Awesome. Okay. Yeah. So join the Discord. Someone's saying join the Discord. Bacon's saying join the Discord. So everybody's in Discord. Even I'm there.
Yeah, we
So
don't. Well, I mean, interestingly, we don't have a official Discord, but we do have presence. Like Jordan and I are in multiple Discords.
yeah.
So
Okay.
yeah, yeah,
Okay. Awesome. Great. Um, Pone College.
yeah.
It's a good start. Okay. Well, I think that's it then. Thanks everyone for your time joining the stream. And next week, Hannah Kane talking machine learning and AI and all sorts of great stuff there. So hopefully you join us and definitely um, we will do this again. So I guess until next time, thank you for your
Yep.
time and effort and for showing off some cool features. And we'll be in touch.
Sure. Thanks
Okay.
for hosting me. Yeah.